Okay. So basically kitchen hood means so this is called kitchen hood. In generally we call it as a chimney, right? So this is kitchen hood. Okay. So here we need to design this kitchen hood. So kitchen hood or it's also called as canopy. So the kitchen hoods are divided into two types. Are classified into two types. One is single skin hood and second one is double skin hood. One is single skin hood and second one is double skin hood. So in the single skin hood, only exhaust system is provided. Only exhaust system is provided. Whereas in double skin hood, exhaust as well as the fresh air system is provided. Okay. Again, these hoods are further classified into two types. One is wall type hood and second one is island type hood. Wall type hood, island type hood. Wall type hood and island type hood. Now, now let's calculate the hood sizing. Consider this as a stove or a burner. Okay. Now let this will be width dash into L dash. The stove size is width dash into L dash, and this will be width and length, and this will be the height of the installation, H. Okay. Therefore, let the hood size be, let the hood size be width into length. Let the stove size be width dash into length dash, and H be the height of the installation. That is the distance between the stove and hood. The distance between the stove and hood. Okay. The distance between stove and hood. So therefore, W equals to width dash into 0.8 into H. L equals to L dash. It's not into, sir. I'm sorry. Width dash plus L dash plus 0.8 into H. This is hood size. This is hood size. Therefore, exhaust CFM. Exhaust CFM equals to to find exhaust CFM, let P be the perimeter of the hood. Perimeter of the hood. Therefore, P equals to 2W plus L for wall type. P equals to 2W plus 2L for island type. Now exhaust CFM equals to exhaust CFM equals to 100 into P for light cooking. 150 into P for heavy cooking. Sorry, this is for medium cooking. $200 into P for heavy cooking. So heavy cooking means the applications like where we cook for long time, like KFC, McDonald's, Pizza Hut. Okay, this will be in the heavy cooking. 150 into P is like restaurants, small restaurants, and 100 into P is for residential applications. Okay, fresh air CFM equals to fresh air CFM equals to 85% of exhaust air. 85% of exhaust air. Air velocity for exhaust system for ventilation system B ventilation system B 1500 to 2200 FPM feet per minute. Some points to be noted here. Duct should be terminated 40 degree above the roof. That means if this is the roof, when you run the exhaust duct straight like this, then what happens when there is a enter here? So what we do is we take 40 degree and we exhaust like this. Okay, so this is exhaust mode. This is the 40 degree like this. If you see here, it should be 40 degree. Okay, so this is how you need to terminate. Next, clean outs should be provided at the base or the riser and every 20 feet of the duct. Cleanouts is nothing but it is the access doors to the ducts. So where effluents will be more, there will be a more greasy particles will be settled on the duct. So to clean that we use. And the duct metal gauges. (16 gauge of galvanized steel. And if you are using 18 gauge of SS 304 SS, which is food grade 304 stainless steel. So this is the points we need to remember while designing the kitchen ventilation system. So simply make a note of this. Make a note.
मोदा हुआ था बोल रहा। छोड़ा कि नहीं? मीठा है।
Is it done?
No, sir, wait.
Let's work on one small sum. Let the stove size be 90 by 70 centimeters and height of the installation is 85 centimeters. Find out the following for island type hood. Half heavy cooking. hood size, exhaust fan capacity, fresh air fan capacity. Okay, so the value is L dash is 90 centimeters and W dash is 70 centimeters. Now L equals to, and H value is 85 centimeters. L equals to L dash plus 0.8 into H, right? Which is L dash is 90 plus 0.8 into 85. What is the value you will get? What is the value?
158.
158 centimeters you will get, right? Which is 1.58. Which is 1.58 meters.
Meter.
So 1.58 meter convert into feet. 1.58 into 3.2.
278.
How much you will get?
Wait.
1 meter equals to 3.28 feet, right?
17 feet.
17?
Yes.
Sir, 1.58 into 3.28. How much you get?
5.18.
5.18 feet. Okay. Same. W equals to W dash plus 0.8 into H. Therefore, W dash is 70 plus 0.8 into 85. How much will you get here?
$138.
138 centimeters, which is 1.38 meter. Therefore, 1.38 into 3.28.
4.52.
4.52 feet. That means the hood size in a commercial kitchen, for that stove size, you need to maintain a hood size of 5.18 feet into 4.52 feet. Hood size equals to 5.18 into 4.52 feet. Next, this is the hood size. Next, perimeter. Perimeter for island type. P equals to 2W plus 2L, which is 2 into 5.18 plus 4.52. How much will you get here? 19.2, right?
$19.4, sir.
19.4 feet. Therefore, exhaust air is equals to 200 into P for heavy cooking, which is 1940 into 19.4 into 200. How much will you get here?
3880.
3
880.
3880.
80.
80 CFM. So you need to exhaust this much of CFM. Fresh air is equals to 85% of exhaust air, which is
3298.
0.85 into
3880.
0.85 into 3880. How much will you get?
3298.
3298. Approximately 3300 CFM. See here, if you notice once, we are supplying less, fresh air is less, and we are exhausting more. That means there is a negative pressurization. You are creating a negative pressure inside the kitchen. So this is kitchen. Okay. Now I am creating a negative pressure here. How I am creating negative pressure? I am supplying, how much I am supplying? 3300 CFM, and I am exhausting 3880 CFM. That means when it creates a negative pressure here, then the air in the surroundings, इधर कुछ रूम्स है तो ये सराउंडिंग रूम्स का एयर इसके अंदर जाएगा. Okay, so when you create a negative pressure, this air moves to here, so that the smoke which generates here will never able to travel to these rooms. इसलिए आप KFC, मैकडोनल्ड्स, पिज्जा हट में गया तो भी इवन व्हेन यू आर एबल टू सी द सी थ्रू किचन, ओके, वो सी थ्रू किचन होता है, किचन ओपन होता है, फिर भी उधर उतना कुकिंग होने से भी उधर से स्मोक इधर नहीं आता है, क्योंकि इधर पॉजिटिव प्रेशर है वेयर वी आर सिटिंग, एंड इन द किचन नेगेटिव प्रेशर है, सो दैट एयर ऑलवेज ट्रेवल्स इन दिस डायरेक्शन. ये डायरेक्शन पे ही एयर ट्रेवल होता है. Okay, that is the funda here in the kitchen ventilation system. Got it? Next, make a note of this. Make a note.
Done, sir.
Done, sir.
So coming to the car parking ventilation system. Suppose this is the car parking area. Width into length is 40 feet by 20 feet. Height equals to 10 feet. Now to find the exhaust and fresh will be the same here. To find the CFM, exhaust CFM equals to, already these calculations we did, if you remember. Exhaust CFM equals to volume into air changes divided by 60. Okay, this is the base formula for ventilation. Any ventilation, this is the base formula. Okay, air changes for car parkings is equals to 15 to 25 air changes per hour. 15 to 25 air changes per hour. Okay, so now we'll calculate that equals to 40 into 20 into 10 is the volume. Volume is equals to length into width into height into air changes. 15 divided by 60. So what is the CFM we'll get here? What is the CFM we'll get here?
2000.
2000 CFM. Okay. So here exhaust and fresh air will be the same. Okay. Here exhaust and fresh air will be the same. So we'll run the as this is 20 feet. For every 12 feet, this can throw the air in 12 feet, sir. Here also we go with one supply. As it can throw 12 feet in one direction, here we use grills basically. Like this, we will use grills. For every 12 feet, this length also 12 feet you can maintain. Like this, we use grills. So this can throw up to 12 feet. Throw distance will be 12 feet. Now the exhaust. Here we are using the exhaust duct. Okay. So some applications, what we do is supply we give from the bottom. Suppose this is the floor. So what we'll do is we'll run the duct like this. To the bottom we'll run. From the bottom we'll throw the air like this from the floor. Unidirectional flow maintain karta hai. So that this air will throw like this and will move to the top. So in the top we'll have a return duct. So if it is possible to take the air, okay, if it is possible to take the air takeoffs, okay, then you can use this system. This is the best designing system. If it is not possible, you can go with ceiling to ceiling only. Okay, so this is how we need to design the kitchen ventilation system. Here also 1500 to 2200 is the exhaust velocities. Okay, next. Yeah, Dheeraj, you have some doubts, right, with respect to project?
Yes, sir.
Yeah, remaining people you can make a note. Yes, Dheeraj, what is your doubts you have?
So what will be the application for that drawing? Because we need to consider
office application.
Okay, it is for the selection of the CFM per person, CFM per square feet. No?
Yeah, it's an office application.
Okay, sir. Also, in the first room, the electrical room is there. So, do we need to
Electrical
consider
room
it
is
in
non-AC. Consider it as a non-AC.
But do we need to consider it in room 1 or it is separate one? It is in the room 1 itself or is the separate
No,
one?
it is a separate. Electrical room is separate.
Okay, sir. Also, a lot of dimensions are not given, so we need
You need to measure it. As you have an AutoCAD drawing, you need to measure it.
Yes, sir.
If not, if you get a PDFs, then we can't measure it. We'll ask for AutoCAD drawing or we'll ask
And
for
are we supposed to round up the values to the nearest?
No. Exact dimensions.
Exact values.